Okay, so today's homework is about relating graphs to tables and relating tables to graphs. Primarily, recently we've been working with graphs. You might want to think of this as in what will it look like in a table, but if you are truly literate in algebra, and that is one of the goals of this course, you will be able to look at a table, and just by noticing how much each x is increasing or decreasing, be able to look at how the y's, the corresponding values in y, how they are going up or going down, and you hopefully will be able to envision what that might look like on a graph. Similarly, you will hopefully, with fluency, be able to look at a graph and anticipate what the table of that graph might look like in terms of y values rising and falling as x values change. In a connection which is forever present in science, particularly in science experiments, it's important to note which of the variables in these graphs and tables is the independent variable and which of the variables is the dependent variable. If you'd like to start with a nice simple rule, the independent variable will always go on the x-axis. Therefore, if you want another rule, the dependent variable will always be on the y-axis. Another important hard and fast rule is that time is always on the x. Time is always going to be independent. In the world that I live in, it's very hard to change the rate of time, and I haven't been able to do any experiments which will change time in my life. Time goes on the x. You might want to make a note of that. Another way to clarify this in your head is if you were imagining the data above being an experiment you did about the rate of cooling of a glass of water placed outside on a chilly day. To determine which variable, temperature or time, were the independent, which one was the dependent variable, you can ask yourself a question. Is the temperature of the water in the glass dependent upon the amount of time that has passed in the cold environment? Or is the time in the cold environment dependent upon the temperature of the water? Hopefully you will say that the temperature depends upon the amount of time it is outside. Therefore, the temperature is dependent upon the time, which is independent. The data from the table, when placed into a graph with a consistent interval, will start to show a trend that you can see. This view is graphically more effective, but less precise. For example, you have gotten 4 discrete value points. This is not continuous data from the table. In the real world, it is continuous data, and if you had, for example, a LabQuest probe in the glass of water, you might have continuous data that would allow you to have all of the points in between each little section on the graph filled in so that you could know the temperature and exact time it was at that temperature during the span of the experiment. One of the limits of the table is that it does not give you every value point. One of the strengths of the table is that it gives you exact value points, discrete points where you know exactly the temperature and time. So an advantage you would want to note for a quiz or a test, an advantage of a graph is that it gives a tremendous amount of information visible in a manner that's easy to see in terms of large general patterns. The advantage of a data table is that it gives you specific values that allows you to know for sure exactly some points that are on the line. The disadvantage of a table is that large general patterns may not be readily visible. Each of these two views is valuable in its own way. You should be able to recognize these points, speak about them, even write small essays about them, about their strengths, their weaknesses, which way you would choose to represent data in various situations. Being able to recognize this and speak about this is a very integral part of algebraic literacy, and thereby something that makes you far more literate and far more able to communicate scientifically. For your first piece of homework, please make a graph with even intervals and fully labeled units in both x and y axes, showing your best guess of the relationship between the time you spend studying for a language quiz and the grade you will receive on that quiz. Needless to say, this is a little bit hypothetical. It's very important before you do this graph that you decide in your mind which of these variables is independent and which of these variables is dependent. If you are unsure, please rewind this video a couple slides and review how you make that choice. For the second question, if you could kindly make a similar graph estimating your working vocabulary. In other words, how many words in the English language can you use with fluency in a sentence, and the amount of reading you do. Units are left out of this at this point, so it'll be important for you to figure out what is an appropriate unit to use in this graph and how you will represent that on the scale. Also very important is which one of these is the independent variable and which one of these is the dependent variable. The last section in this unit is about synonyms and vocabulary. To be truly literate in algebra, you must be able to know all of the above terms which are part of a working vocabulary for an algebra or science student. Please take a minute to write these two columns down. The items on the left are all synonyms for one another. The items on the right are also synonyms for one another. In other words, they can be used interchangeably. Typically, however, they will be used together as listed. In and out. You put in an input, you get an output. You have an item that's from a domain, it comes out in a range. You have an independent variable, it relates to the dependent variable. Y is dependent upon X. X is independent, Y is dependent upon it. X is independent, the output of X is f of X, or the function of X. Typically they will be used as they are paired, but you should be able to substitute them mentally to know that they are all basically different words or synonyms for the same concepts. The first time you may have been introduced to this was possibly in lower school, where there was a box, and they called that box the rule box. And you had this number that would come, and basically it was an input. And that number would go into this rule box, and out would come some output, some range value, something that was dependent upon, one, the value of this input, and two, the rule, whatever it was that happened to it. If the input was 5 and it came out as 7, if the input was 6 and it came out as 8, if the input was 10 and it came out as 12, the game in that rule, the game was to figure out what is the rule. In this case, it would be x plus 2 is what the output is equal to. X plus 2 is the rule. It's the function. It's the thing that changes the input into the output. Please write these down. Please know these pieces of vocabulary just as if you were studying for a world language quiz.